Hello. So, part of my research is to understand wireless localization with low power network applications. And in order to understand that, I had to do some research about IoT and how I can use the Zigbee yet to be helpful in these applications itself. So, I'll be going over the importance of the different modes that are used in the Zigbee and how I'm able to use a range test to discover how far away the Zigbees are able to communicate to each other, creating a very powerful performance. And this will just be a very quick video of this. So, first things first, I just want to describe the Internet of Things, which is just a network of physical objects that are embedded with softwares, sensors, and other technologies in order to connect and exchange data with other devices and systems over the Internet. We use the Internet of Things for many smart devices like washing machines, cars, even microwaves and such. So this process, the Internet of Things, is going to be used for a very long time, for many generations. And we are here to just research more of its capabilities. And in order to do that, I will be using a Zigbee Mesh Network Development Kit. And to just go over what a Zigbee is, it is a wireless technology developed as an open global standard to address the unique power of the low cost, low power wireless IoT networks. And with the mesh networks, they are just nodes that are just interconnected with other nodes. So we'll be able to manipulate the network. And if we're able to understand the importance of the mesh networks, we can use it to communicate to other Zigbee devices and just measure the signal strength for low power applications. Just a very quick definitions of the coordinator router and end devices. These are the device types that we'll be using to manipulate the network. For the coordinator, this is just used to uh, allow routers and end devices to join the network. It is the boss. It is the one that is in charge of making sure that everything is secure, managed, and all networks are healthy, no viruses whatsoever. The router is just used to join existing networks to just send, receive information. It is used to act as a messenger for other communication devices uh, in order to be able to communicate the packets that are needed for the coordinator. And the end device is basically like a router. It's also able to send and receive information, but the end device is not really a messenger and it can be a little bit slow to relay information, but the end device is less expensive hardware and you just use it to save up energy. Now, the difference between the API and the AT. So, the AT is the transparent mode, which is used to just copy and paste information that is just sent to the coordinator as it is without manipulating the transmission or how it is received. And the API is the application programming interface. With this, we can actually manipulate how data is sent. It's a little bit complicated, but it is very well rewarding as there are many advanced features, as we're able to receive data and even see any reasons for how the data has been sent or not sent to its respected nodes. Now, some quick advantages of the transparent mode is that it's very easy to use. We can just simply use it for simple two-way communications between Zigbees. Yeah, however, we're not able to read the way how the information was configured in the network, and we can't really identify the data, unlike with API devices, where we can actually, again, transmit data to multiple destinations and we're able to understand how that information was sent. And I will be doing some demos personally to show how the API and AT are useful for the Zigbee devices and how we can also use this for our project. Lastly, I have done a range test, which is used to just demonstrate the real world radio frequency range and the quality between the Zigbee modules, just to basically make sure that the Zigbees are, yeah, are healthy in the way how data has been sent, no matter how far away the Zigbees are to each other. Information has been sent properly. So I have done a range test with, yeah, with my Zigbees already, and this is the result. As you can see here, the range test process is has to retrieve data in three ways. We have this RSSI chart, which represents the values of the local and remote devices for the range test session. This represents the percentage that is being sent, yet that's been a success to the other Zigbee, and yet and how our local RSSI information is being processed with very little noise or any obstacles in its way. We also have our local and remote instant RSSI value display, which is used to make sure that the last packet has been sent or sent in or received. And we have the value of our packets and how many has been sent. Again, there's sometimes maybe some packet loss because of the noise or the way how my Zigbee devices have been set up. Maybe because there was a wall in the way or some major dust particles. This can all be a reason why some packets could be lost. But the range test was very, very useful for me to make sure that my data has been sent to another Zigbee and there was no obstacles in the way for that information. And of course, we will be able to use this to help, to for our project with our Raspberry Pi to be able to create a sensor project for our construction workers to be able to understand if there is an obstacle in the way or and if the information hasn't properly been sent to the other Zigbees to communicate with. Thank you so much.